The basin sits at a slight elevation above the surrounding land, enclosed on three sides by rock. The stone faces rise unevenly, weathered by long exposure to wind and temperature. Their surfaces are rough, fractured in places, darker where water has run and lighter where sun has reached them consistently over decades. During the day, the rock absorbs heat slowly. At night, it releases that heat at an equally measured pace. Seasonal variation defines the place. Summers bring dry air and wide swings between day and night temperatures. Winters are cold but stable, with fewer sudden storms than in the open valleys below. Snow settles in shaded pockets and melts unevenly where stone retains warmth. Wind moves predictably through the gap between the rock faces, accelerating slightly in the afternoon and calming after sunset. Vegetation is sparse but persistent. Low shrubs grow where soil has collected in cracks. Lichen spreads across shaded surfaces, indicating long periods without disturbance. Animal tracks appear intermittently, mostly small mammals and birds. Larger animals pass through but do not linger. The location is isolated, though not unreachable. No roads lead directly to it. Access requires deliberate travel on foot or by rough track. From a distance, the basin appears unremarkable, almost concealed by the surrounding terrain. Only when standing within it does the shape become apparent. The stone dominates the space. It defines the temperature, the sound, and the sense of enclosure. Before any structure exists, before any tools are used, the rock already controls how heat moves, how air settles, and how long a human body might endure here without artificial shelter. The man who settled in this basin did not arrive as a castaway. He came by choice, during a period when withdrawal from modern infrastructure was neither fashionable nor well supported. The era was one of expanding grids and centralized heating systems, yet pockets of experimentation persisted among individuals who believed shelter could be shaped by geography rather than fuel. He was not alone in this thinking. Throughout the mid-20th century, small numbers of builders, homesteaders, and engineers tested passive methods of living in cold climates. Some were trained formally. Others learned by observation, repetition, and failure. The record surrounding this particular man is incomplete, preserved through secondary documentation rather than personal journals. What is known comes from land records, later interviews, and physical examination of the structure itself. He arrived with limited resources. There is no indication of mechanical equipment being used in the initial stages. Materials were gathered locally when possible. What could not be sourced from the land was brought in deliberately and sparingly. The decision to remain was not impulsive. Prior visits to the site suggest he had observed the basin across seasons before committing to construction. His motivation was practical rather than ideological. Fuel was expensive and difficult to transport. Winters were long. Firewood required constant labor. The stone formations presented a possibility that had been considered elsewhere but rarely executed in such a confined form. If the environment already stored heat, it could be used directly. He did not intend to disappear. The site was remote but not secret. Occasional contact with nearby settlements continued, though infrequently. What separated him from others was duration. He stayed through winters that drove most people back toward towns. Over time, the cabin ceased to be an experiment and became a permanent dwelling. By remaining, he accepted the limits of the place. Once the structure began to take shape, leaving would mean abandoning not only labor, but a system that depended on precise positioning. The choice to stay narrowed future options. It also fixed his survival to the behavior of stone, sun, and time. The knowledge he brought to the basin was not specialized in the academic sense. There is no evidence of formal architectural training or engineering certification. What he possessed instead was familiarity with materials and patience with process. He understood wood from years of use rather than theory. He understood stone from handling it, observing how it fractured, how it held cold, and how it retained warmth after long exposure to sunlight. His understanding of heat was functional. He knew that mass mattered more than insulation alone. He had seen how masonry buildings stayed cool in summer and slow to freeze in winter. These observations were not unique, but applying them deliberately to a small, Isolated cabin required confidence in outcomes that could not be fully tested in advance. Passive solar concepts were already documented elsewhere by the time he began planning. South-facing walls, thermal mass, and controlled airflow had been discussed in agricultural and experimental housing circles. What set this site apart was the scale and the reliance on existing geology rather than constructed mass. The stone walls were not decorative or protective additions. They were the primary thermal component. He prepared by observing rather than calculating. Sun angles were noted over months. Shadow lines were marked directly on rock. He returned at different times of day and in different weather. These visits informed where a structure could sit without blocking light in winter or overheating in summer. He also understood his own limits. The design avoided complexity. There were no moving parts, no mechanical systems that could fail without replacement. The goal was not comfort by modern standards, but stability. A place where temperature did not dictate constant labor. When construction finally began, it reflected accumulated observation rather than innovation. Nothing about the plan was radical on paper. What made it unusual was its precision. The margin for error was small. If the cabin sat too far from the stone, heat would dissipate. Too close, and moisture and cold transfer would become problems. What he carried into the basin, then, was not a blueprint. It was a set of constraints already accepted. The land would not be altered to fit him. He would be placed within it carefully and remain there. Construction began without ceremony. There was no clearing of large areas, no attempt to reshape the basin beyond what was necessary. The first work involved leveling a narrow strip of ground between the two rock faces. Soil was shallow. In places, bare stone emerged just beneath the surface. Rather than removing it, he incorporated it, adjusting the footprint of the structure to rest where the ground was already stable. Materials accumulated slowly. Timber was cut and hauled by hand. Each piece brought into the basin had a clear purpose. Excess weight meant additional trips. Each trip increased exposure to weather and injury. The pace was deliberate. Weeks passed without visible progress from a distance. The placement of the cabin fixed everything that followed. Once the foundation line was set, it could not be adjusted without dismantling what had already been built. The rock faces defined the outer limits. The structure would sit close enough to benefit from the stored heat, but not so close that seasonal moisture seeped directly into the walls. That balance was established through trial placements of temporary supports and repeated observation after rain and frost. At this stage, leaving was still possible but increasingly impractical. Tools had been cached. Timber had been shaped specifically for this site. The work already invested could not be recovered or relocated. More importantly, the design itself was inseparable from the basin. Building the same structure elsewhere would require starting again from observation. The moment of commitment was not marked by a single event. It emerged gradually as options narrowed. When the first permanent wall section was raised, the choice became clear. From that point forward, progress meant deeper dependence on the success of the system he was constructing. There was no contingency shelter prepared elsewhere. The cabin was not a supplement to another dwelling. It was intended to stand alone. As the walls rose, they enclosed not just space, but time. Seasons would now be experienced from within this fixed position, subject to how accurately the stone and structure worked together. Once enclosed, the basin would no longer be a place he visited. It would be the place where outcomes were determined, without the possibility of easy retreat. Before the cabin could function as intended, the stone had to be understood not as a barrier, but as a system. The two rock faces were not identical. One received longer exposure to direct sunlight, especially in winter when the sun traveled lower across the sky. The other remained in partial shade for most of the day, warming more slowly and cooling earlier in the evening. This imbalance mattered. He tracked these differences without instruments. Marks were placed where light reached at different hours. In winter, the sun touched only the upper sections of the eastern face, leaving the lower rock cold throughout the day. In summer, light penetrated deeper, warming the stone unevenly. These patterns repeated predictably. The rock behaved consistently across seasons. Wind was the second variable. Air moved through the gap between the stone faces like water through a channel. During cold months, wind increased heat loss if allowed to pass directly through the living space. The cabin's orientation reduced this exposure by placing its smallest exterior opening toward the prevailing winter wind. In warmer months, that same channel allowed excess heat to be drawn away naturally. Moisture presented a quieter risk. After rain, the stone darkened and cooled. Meltwater from snow followed narrow paths downward, collecting at the base of the rock. These flows were mapped mentally and avoided in the final placement. The cabin floor was raised slightly where seepage was unavoidable. There was no attempt to seal the stone completely. Instead, airflow and drainage were allowed to manage dampness over time. The thermal behavior of the rock defined daily rhythms. After long periods of sun, the stone radiated warmth well into the night. During extended cloud cover, the effect diminished gradually rather than collapsing suddenly. This delay was the core advantage. It reduced the urgency of constant intervention. He adjusted the structure incrementally to reflect what the stone revealed. Wall thickness varied depending on proximity to the rock. Openings were kept narrow and placed where heat retention mattered less. Nothing was symmetrical unless the environment already was. By the time the cabin reached functional completion, the stone was no longer observed actively. Its behavior had become predictable. The environment no longer required constant reassessment. Instead, it imposed limits that were already understood. The success of the system depended on this early attention. The cabin did not generate heat. It managed delay. It slowed loss. The stone did the rest, quietly, without maintenance, as it had for centuries before the structure was placed between its faces. With the behavior of the rock established, construction moved from observation to execution. The cabin was built inward rather than outward, constrained deliberately by the stone on either side. This was not an aesthetic choice. The narrow span reduced exposed surface area and limited heat loss. Every dimension was influenced by what the rock allowed. The foundation followed the uneven ground rather than correcting it. Where bedrock rose naturally, it was incorporated as part of the floor support. Where soil was deeper, stone and timber were layered to create a stable base. There was no concrete. Weight was distributed carefully to avoid shifting during freeze and thaw cycles. The walls nearest the rock were built heavier than those facing open air. Timber framing was reinforced where contact points were closest, but direct contact was avoided. A narrow air gap separated wood from stone, preventing moisture transfer while still allowing radiant heat to move inward. This gap was small enough to remain warm but wide enough to stay dry through seasonal changes. Roof placement was critical. It extended just far enough to shed water away from the stone faces without blocking winter sun. In summer, when the sun rose higher, the overhang reduced direct heating, preventing excessive warmth inside. This balance reduced the need for any internal adjustment. There were few openings. One primary door and a limited number of small windows were positioned with restraint. Each opening represented potential heat loss. Their placement favored light over view. The interior remained dim compared to modern standards, but stable. Construction took time. Progress slowed during colder months, when working by hand became more difficult and daylight shortened. There were pauses where no visible work occurred. During these periods, the structure stood partially complete, exposed to the same conditions it was being designed to manage. These intervals served as unintended tests. By the time the final wall sections were enclosed, the cabin had already endured multiple weather cycles. Minor adjustments were made. A joint tightened. A drainage path widened. Nothing required redesign. The form held. The finished structure did not stand out against the basin. From a distance, it appeared recessed, almost incidental. The strength lay not in resistance, but in alignment. It did not challenge the stone. It depended on it. Once complete, the cabin ceased to be a project. It became a fixed element within the basin, shaped by limits already accepted. From this point forward, survival would depend less on construction and more on how the system performed over time. The first winter tested the system without ceremony. There was no clear dividing line between success and failure, only gradual confirmation that the interior temperature changed more slowly than the air outside. During cold nights, the stone walls released stored heat at a steady rate. The effect was subtle but persistent. The cabin did not remain warm by conventional measures, but it avoided sudden drops that forced constant response. Fire was used sparingly. When it was lit, it served a specific purpose rather than ongoing comfort. The heat from combustion supplemented what the stone already provided, raising the interior temperature enough to charge the surrounding mass further. Once extinguished, the benefit lingered. This reduced the frequency of fuel gathering and the labor that came with it. Daylight played a direct role. In winter, when the sun reached the rock faces for only a limited window, that exposure mattered. Clear days produced measurable gains. Cloud cover reduced input, but the loss was delayed rather than immediate. This delay was the central advantage of the system. It transformed weather from an urgent threat into a variable with momentum. Inside the cabin, temperature gradients were noticeable. Areas closest to the stone remained more stable. Air circulated slowly, driven by small differences rather than forced movement. There were no fans, no vents beyond those required for smoke and minimal airflow. The environment adjusted itself within narrow limits. Condensation was monitored closely. Excess moisture threatened insulation and comfort. The air gap between wood and stone proved critical. It allowed warmth to pass while preventing dampness from settling into the structure. When moisture did appear, it dissipated over time without intervention, provided ventilation remained controlled. The system required awareness rather than adjustment. Doors were opened and closed with intent. Fires were lit only when the stone could benefit. Daily routines aligned with thermal cycles rather than opposing them. This reduced the sense of struggle. The environment did not need to be conquered. It needed to be read correctly. Over multiple seasons, performance remained consistent. There were no dramatic failures and no sudden improvements. The cabin behaved as it had been designed to behave. Its success lay in predictability rather than comfort. Heat, in this place, was not produced. It was delayed, redistributed, and conserved. The stone did not warm the cabin actively, prevented rapid loss. In a landscape where extremes defined survival, that restraint was enough.